Great. Good afternoon. My name is Byron Miller. I'm the head of digital scholarship and technology at the American Philosophical Society. Welcome to the second day of the APS's virtual symposium, The Promise and Pitfalls of Citizen Science. I'm glad that so many of you joined us today. The American Philosophical Society resides in Lenape-Hoking, the homeland of the Lenape people, whose historical relationships with the land continue to this day. The APS acknowledges with respect their continued presence and perseverance, and expresses its sincere thanks for the past and ongoing generosity of numerous Indigenous communities and individuals who have offered their guidance, expertise, and opportunities for collaboration. This week's conference is inspired by the Society's 2021 exhibition, Dr. Franklin, Citizen Scientist, and expands on the exhibition's themes by exploring understandings of citizen science over time, placing historical initiatives in conversation with present-day projects, as well as reflecting on the future needs and opportunities of the movement. For those joining us for the first time, the American Philosophical Society was founded by Benjamin Franklin in 1743. The Society is a catalyst for the discovery of new knowledge. Election to membership honors those who have made exceptionally significant contributions to science, the arts and humanities, and public life. The Society promotes research by providing over $1 million in research grants a year, primarily to younger scholars who need the support the most. Our library and museum collections and research centers serve scholars and visitors from across the globe. Please do check out our website, amphilsoc.org, to learn more about what we do and for news for forthcoming events. So today we're using Zoom webinar, so not to worry, you've all been muted. If you have a question, please use the Q&A button at the bottom center of your navigation bar. You can type your question in there at any time during the presentations. There'll be time at the end of the panel for questions with our speakers. We also encourage you to keep the conversation going on the APS social media using the hashtag #CitSciAPS. Pages from today's speakers are available for download from the conference website and may be accessed using the passcode CitSci2021. Finally, we're excited to offer closed captioning for this conference. If you would like to use it during the panel, please click on the CC button at the bottom navigation bar of Zoom. It's to the right of the Q&A button. So with that, it's my pleasure to introduce the presenter for today's panel on historical perspectives. Jin-Woo Choi is a third-year PhD candidate in the history department at Princeton University, working on a dissertation provisionally titled The Cold Standard, Meteorology, Seasonality, and the Making of Great Winters in Early Modern Europe, 1608 to 1740. He is interested in various aspects of the history of meteorology and weather knowledge, from cosmography and astrology to instrumental observation, as well as their social and cultural applications, especially concerning the seasons and their variation. Cristina Luís holds a PhD in biology and is a researcher and lecturer at the Faculty of Sciences, University of Lisbon, in the areas of science communication, citizen science, public engagement, history of science, and history of horse domestication. She is also a member of the Inter-University Center of History and Science and Technology. Since 2010, she has been involved with coordinating several citizen science projects and initiatives, including the NewsEra project, which explores citizen science as a new paradigm for science communication. She's a team member of the EU-funded Project Enjoy and conducted the first mapping of citizen science projects in Portugal. She has been invited to organize citizen science workshops, sessions and congresses, and is promoting the establishment of a Portuguese citizen science network. Cristina is also chief editor of the Journal of History of Science and Technology. Finally, Peter Davidson is a senior curator of minerals at National Museum, Scotland. His research focuses on the history of mineralogy and geology, particularly the period between the mid-18th and mid-19th centuries. He joined the museum as a museum assistant in the former Department of Geology in 1975 and helped to establish and run the new X-ray analytical facility. As well as curating the mineral collection, he also looks after the museum's collection of meteorites and has a particular love of the museum's 18th-century crystal model collection. He's also planned and developed many permanent and temporary exhibitions, both in the museum and at mineral shows in Europe and the USA. With that, welcome Jin-Woo.
Well, many thanks for the kind introduction. I'd first like to thank Adriana Link, Carl Roberts, Byron Miller, Maggie Hoot, and everyone else at the APS for putting together this wonderful event and the opportunity to present. Now, next slide, please. Now, weather observation has been practiced for millennia, but the turn of the 18th century saw a rise of interest among Europeans in observing and recording the daily weather in numerical terms. This was motivated in part by Enlightenment aspirations of useful knowledge attained empirically and applied ubiquitously for the benefit of society. An improved science of meteorology, as one of its 18th century proponents noted, would bring about the perfection of agriculture and medicine. But to account for the deep-seated causes of the meteorological phenomena and patterns would require legions of observers scattered around the world. Who was deemed suitable to participate? Whose records were seen as reliable enough for usage? When we think of those who kept track of the weather, the pioneers of empirical meteorology, we think of the greats like Robert Boyle and his project for a general history of the air, or of John Locke and his register for the weather. They are obviously important, but not entirely always representative. In my paper, I revisit the figure of the early modern weather observer and the question of how to think about citizen science in a period long before the term was even conceived, by focusing on two cases of what I would call group observation. And with these examples, I hope to show that first, weather observation as a scientific activity in this period wasn't always a solitary endeavor. Second, observers varied in their professional backgrounds. But third, that doesn't always mean everyone was invited. And finally, fourth, the case of pre-19th century meteorology presses us to consider the roots, or perhaps the precursors, of citizen science avant la lettre. In dealing with this tricky question, my approach is to take the two words separately. Citizenship was, of course, far more exclusive a status and less common a concept in this period. Meanwhile, science was less institutionalized, less professionalized, and encompassed not just the natural sciences. So in fact, the most systematized sciences in this period were theology, law, and medicine. By contrast, meteorology, natural history, botany, and even chemistry, and to some extent physics, all had relatively lower entrance barriers and attracted an eclectic crowd of contributors. Now, to get to the roots of modern-day citizen science, we need to reconsider all familiar categories and put on our historical lenses. We now turn to a mid-17th century Tuscan church as our first example. The Abbey of Valonbrosa may appear to have little to do with the cutting-edge science of its day, but it was the monks there whom the Grand Duke and his court philosophers had in mind as the ideal candidates for their latest ambitious project, a weather observation network covering Italy and reaching beyond the Alps. Like all other participants in this Medicean network, the monks of Valonbrosa received the same glass-blown 50-degree thermometers and identical instructions for measuring temperature. Sure enough, the monks proved to be the perfect observers due to their punctuality and regularity. But what I found most striking while going through their manuscripts were traces of what appears to have been a system they set up to keep the work going uninterrupted. Father Filiberto Cassini was the original scribe in charge of the weather records. But as we see here, during days of his absence, he had someone to fill in for him, in this case, Niccolo Signorini. We have the same recordings at the exact same times. Not a single day was lost. Even more impressive is what happens when one of the observers is gone for good. Cassini died on the last day of July 1656. He laid down his pen after his last entry on the 20th, just 11 days before passing. Immediately the day after, a new signature appears. Cassini's junior colleague, Petronio Tacheschi, seamlessly took over the scribal role. In this way, the Vallombrosan monks were able to sustain an unbroken series of observations for well over a decade, much longer and more consistent than any other participating node in the Medici network. So teamwork certainly paid off. Now, from this 17th century abbey, we travel about 40 years forward to a family of astronomers in Eastern Germany. Gottfried Kirch, Maria Margherita Kirch, and their children compiled what is widely known as the oldest surviving weather diary from Berlin. The Kirche started the first state-funded observatory in Berlin out of their rooftop apartment, and Gottfried was employed by the new Prussian Royal Academy of Sciences. Maria may not have had an official title or fancy degree, but she was a well-reputed astronomer in her own right, who made important discoveries and corresponded with some of the greatest intellectuals of the time, including Leibniz. Their only son, Clistfried, later succeeded his father's post at the academy. Despite these illustrious achievements, however, the Kirch family started out small, and their meteorological activities in particular originated from very humble circumstances. Gottfried was the son of his village shoemaker, and though he did go to university, for most of his life he worked as a local calendar maker, applying his astronomical interests to commercial ends. Maria did not even go to school, but instead she learned everything about the science of the stars and weather from the so-called farmer astronomer or peasant astronomer Christoph Arnold. Their interest in meteorology alongside astronomy thus appears to have come from practical concerns about harvests and trade winds from the life in the provinces. Maria wrote in her weather diary that accumulating enough records of the changing weather and spotting patterns over time would eventually provide the foundations for better forecasting, which would help agriculture and sailing. Now, in my paper, I go into the details about the Kirch's recording and observational practices. And here I would really need to thank Professor Stefan Brönnimann at the University of Bern, who very generously shared his photocopies of the weather diaries. One important point I'd like to note here, however, is how the Kirche were able to keep the diary going. Similar to the Vallombrosan monks, the Kirch family passed on the responsibility between spouses and later between generations. When learned societies requested their records, as did the Berlin Academy in 1740 to investigate the harshness of past winters, the family willingly obliged. It's also worth noting that it was the women of the family, Maria and her daughter Christine, who were usually in charge of the weather diaries. The men contributed little by comparison. Due to the pervasive gender inequality of the time and the barring of women from educational opportunities and official positions, Maria and Christine occupied a sort of middle ground or intermediary role between low and high science in that time. This not only meant that observers like them were excluded from certain elite initiatives, such as the well-known Palatine Meteorological Network, but also that acknowledgement for their scientific work often went to the men of the family instead. Now, to conclude this brief talk, these cases, I would like to argue, show that scientific activities took place in spaces perhaps less obvious to us now, such as a monastery or a household, specifically because of their advantages in overcoming some natural limitations of scientific weather observation. Moreover, they demonstrate that weather observers in this period came from various backgrounds. They weren't always leading academicians or professors of physics, and they weren't even always men either. With that said, however, the broader takeaway for thinking about the origins or precursors of citizen science are twofold. First, that it was at once both more exclusive and more inclusive than now. Exclusive in that the centers of scientific activity, like the Royal Academies, certainly had preferences and standards for whom they decided to include. But inclusive in the sense that there weren't strict requirements tied to disciplinary expertise or professionalization or even university degrees just yet. I won't say they didn't exist, but it was still a time when interested amateurs, given enough dedication and ability, could enter a field and become reputable authorities. A prime example being Benjamin Franklin, of course, who with scarcely any schooling ended up gathering quite a fan base among some of the most learned scholars in Europe. The second takeaway, perhaps a little less obvious, but one I hope to have shown to some extent, is that it was in this period, and with meteorology especially, that considerations of science's social utility really came to the fore. Useful science was, of course, an ancient concept and therefore nothing new. But during the Enlightenment, the object that science served, that is the idea of society or the expansion of a scientifically inclined reading public, was new. If we were to look for the origins of citizen science in the 17th and 18th centuries, we would certainly find it most clearly in the spirit of a science in the service of the public and of the greater good. And that is a history lesson we would do well to remember. Thank you.
Hello, good afternoon. After this very interesting presentation from Jin-Woo, we will keep traveling across citizen science, but this time in Portugal. Next slide, please. As a way of bridging the relation between science and society by involving members of the public in scientific discovery across disciplines, Citizen science has gained worldwide increased relevance in the last decade, particularly as a tool to address environmental and conservation issues, and Portugal is no exception. Yet, citizen science activities, and in particular those related to biodiversity monitoring practices, are still fewer in number than those in other countries, although they have increased as this practice becomes better known. Much remains, however, to be done when it comes to studying the implementation and evolution of citizen science in Portugal. A survey conducted at the end of 2016 among the Portuguese scientific community confirmed some lack of awareness among the researchers community as to what citizen science is or what its potentials are. Although the term is no longer totally unknown to many researchers, most understand it more as a way to promote the scientific literacy of populations than as an effective way of public participation in scientific research. And although there are still some doubts regarding what citizen science is, the practice is several centuries old. For centuries, people have been interested in identifying and documenting the occurrence of animals and plants, that is, recording biological data, and literature is full of examples. For instance, in China, both citizens and officials have recorded grasshoppers outbreaks for at least 3,500 years, while in Kyoto, we can find records of cherry blossoms coming into bloom over 1,000 years ago, or in the US lighthouse keepers were approached by American ornithologist unions to start recording birds that collided in lighthouse. Although the long history of volunteer involvement in biological recording is widely recognized as playing a critical role in science and decision-making, the story of biological recording, its distinctive attributes and successes have been largely untold in many countries. Examples of this sort also exist in Portugal. However, an in-depth study on the history of citizen science in Portugal was never conducted, and particularly tracing the history of amateur biodiversity monitoring practices has never been conducted in a systematic way. Compared with other countries such as Britain and Ireland, where the historical legacy of biological recording is unique and inspiring, Portugal does not emerge as an example where this type of practice was very common. So uncovering the history of biological recording in Portugal by revealing how the amateur naturalist communities were formed and evolved, and understanding when and how the public was called to volunteer in biodiversity monitoring practices will be of utmost importance to help explaining why citizen science and biodiversity monitoring practices by non-experts are still residual in this country. To help reconstructing the history of citizen science in Portugal, we are examining the network of volunteer contributors to biodiversity recording and how information circulated among collectors, amateur naturalists, and specialized naturalists. Our analysis focused mainly on the 19th century and the beginning of the 20th century, but we will not limit ourselves to this period if relevant information from other periods becomes available. We are surveying historical archives with particular attention to catalogs and publications held at the National Museum of Natural History and Science, now part of the University of Lisbon. This museum inherited the collections of the Royal Museum and Botanic Garden of Ajuda that was created in 1765 for the education and leisure of the royal family. The documentation available at the Natural History Museum provides, among other important data, information on the specimens collectors. Alongside, we are also analyzing scientific literature from the period under analysis. The documentation at the museum includes a very interesting manuscript on the methods of collecting, preparing, shipping, and preserving natural products that in many points coincides with the text's brief instructions to the correspondence of the Lisbon Academy of Sciences, both wrote in 1781. The curiosity about these texts is that they are intended exclusively for amateurs seeking to make universally accessible some of the less technically complex procedures used by naturalists in the manipulation of natural objects. They are therefore defined as manuals for the dissemination of useful knowledge. The methods of collecting makes it clear from the title that it was conceived by naturalists and written for the use of the curious. This means that although the creation of museological links with royal establishments was favored, the attitude of pure amateur collecting was accepted as socially useful. A similar document was published around 1 century later at the Museum of Lisbon, the institution that inherited the collections from the late Museum of Ajuda, and that originated the nowadays Natural History Museum. Barbosa de Bocage, director of the Museum of Lisbon, published in 1862 the practical instructions on how to collect, prepare, and send zoological products to the Museum of Lisbon. With this publication, the museum director called for the collaboration of individuals to help expanding their zoological collections. It was to those who wished to help the museum that he addressed the instructions. It is very interesting the way this document addresses the population in general and appeals for the collaboration of all those interested in collecting zoological specimens, disregarding any previous experience as an amateur naturalist. The strategy used to encourage people to participate in what we could call as an appeal from the 19th century to become citizen scientists includes both the idea of recognition, but also the idea of contributing for the advancement of the country. It is interesting to note the use of recognition as one of the ways to attract participation. In fact, and although some of the names that contributed with specimens remain unknown because no information could be retrieved about who they are, the truth is that the recognition of their contribution is registered forever in the biological records of the museum. The good results of the strategy established by Bocage can somehow be inferred from the report he published in 1865. He received specimens from around 24 collaborators living in different parts of the country. The region with more contributors was Coimbra. Those studied or taught at the university, and some were quite young and striving for an academic career. The second region with more contributors was Setúbal, a coastal city traditional link to fisheries and with an important maritime port. It is interesting to note that, with the exception of the collaborators from Coimbra who actively pursued an academic career, those who contributed with specimens to the museum did not have a main scientific occupation. Nowadays, some citizen science projects in Portugal struggle with figuring out ways of involving fishermen in biodiversity monitoring. So it will be interesting to bring to light the results of the involvement of these communities in the past so that today's communities feel a greater impetus to contribute to scientific research. We are also analyzing the collections catalogs preserved at the Museum of Natural History and those published in periodicals. This exploratory analysis has enabled gathering already a good number of names that compose the networks of collectors who contributed with specimens to the museum, showing that a considerable part of the collectors were members of the aristocracy, politicians, but also other members of society. As expected, due to the history of the museum, the royal family was responsible for several contributions to the museum collections. But a more thorough analysis, next slide, please. A more thorough analysis about the network of collaborators is still needed. Who were they? Why were they contributing? We are also aware of the scientific work developed by the clergy in Portugal. So one of the following steps will include the analysis of scientific publications produced by this group. Moreover, the work underway is providing evidence of the large number of biological records that are present in all documents that we want well retrieving and turn accessible. Next one, please. Next slide, please. Okay, thank you. With this research work, and to finalize, with this research work under development, we expect to contribute towards clarifying who, within the Portuguese society, was involved in biodiversity collection and description, understanding why biodiversity monitoring conducted by non-experts is an uncommon practice in Portugal, advancing and consolidating the field of history of citizen science studies in Portugal, also help creating accessibility to historical biodiversity records to enable their use in future research, and increasing Portuguese citizens' awareness on biodiversity by enabling their involvement in scientific projects, contributing to a more informed society. Thank you so much. And I would like also to thank all the organizations behind this symposium who did an excellent work. Thanks a lot.
Good evening, everybody. Thank you for joining me this evening. And I would just like to thank the organisers of the conference for inviting me to participate. It was a surprise, I have to say, but I hope to tell you an interesting story of a meteorite and the public participation in creating a little bit of science around the fall and observational notification of it. Next slide, please. The meteorite in question is the Strathmore meteorite of December 1917. The picture that you see, I will give you a slightly larger example later on, is the picture of the house where the meteorite struck the roof and went through the roof to land on the rafters in the attic. One of the most iconic pictures of this meteorite, in fact, probably the iconic picture of this meteorite. Meteorite falls are sometimes thought of as being rather uncommon and rare, but in fact they are extremely common. Depending on which paper you read, there can be anywhere between 20,000 and 80,000 meteorite falls per annum. That's meteorites that are usually over 100 grams in weight. And even though there are these tremendous numbers, very few are actually recovered as a percentage. I think in total, for the whole history of meteorics, there only are about 50,000 meteorites, individual meteorite in museum collections around the world. The Strathmore meteorite was fragmented. It fragmented on entry, and 4 pieces fell in the area that's called Strathmore. It's not a single place. It's a large, broad, fertile valley just to the northwest of Perth, running roughly 20 kilometres northeast of Perth towards the North Sea. Next slide, please. The weather conditions on the day of the fall, this is quite important because, as I'll explain later, it aided the visibility of the meteorite to observers on the ground. The date, as I've said, is the 3rd of December 1917. There was a clear blue sky with little or no cloud cover. The local temperature was really cold. It was -7 Celsius, that's 20 degrees Fahrenheit. The wind speed was very, very light, 1 to 2 miles an hour. The ground was frozen and quite hard, which is kind of germane to the story later on. And the time of the fall was around 1:15, 1:20 in the afternoon. So it was clear sky, lots of people around. And as I'll show you later, it fell over one of the most populous parts of Scotland. Next slide, please. There are only 4 Scottish meteorites, which, despite the size of our country in terms of land mass, is quite surprising. But then in the UK, in total, there are only around about 22. Most of them are falls, and some of them are finds. There is a difference between them. Falls are observed and recovered. A find is simply found serendipitously in the countryside. All the Scottish meteorites fall in what is called the central belt of Scotland. That's the bit in the middle between the Highlands and the southern uplands. It's the most populous part of the country, and it's not surprising that any observed falls will be seen there. The other 3 are the High Postle, which is just north of Glasgow, Perth, from the city of Perth itself, the Strathmore, which we're talking about, and Glenrothes, which is again quite close by to the other 3, not related to them, but again in the central belt of Scotland. Can we have the next slide, please? And this is a map of the central part of Scotland. You can see the red dots indicate where the meteorites fell. They're fairly closely grouped together. You can see the highlands in the north and what's marked as the southern uplands, which are lower hills which mark the border area between Scotland and England. And in the middle is the central belt, and around 60 to 70% of the population of Scotland live in this area. You can already see 3 major cities there, so it's a very populous area. Next slide, please. This is a slightly larger blown up image of the famous hole in the roof. There is a story behind this, and if I've got time, I should probably quickly tell it. The stone did genuinely hit the roof of this house. It's the lodge house on the estate of Keithick, just north of Perth. And the elderly couple standing in front lived in the house with their daughter Elizabeth. They heard something striking the roof, and when they went out, they could see there was a hole, and the daughter scrambled up on a ladder and looked through and saw that there was something sitting on the rafters. They obviously in December in Scotland, you don't want a hole in your roof, believe me, it's the last thing you want. So they quickly called in a tiler or a roofer who came and repaired the roof and also retrieved the meteorite and gave it to the family. Now, the newspapers had gotten wind of the story. It started to appear, letters were appearing in the paper, and I'll talk about these later. So they sent a journalist up to the house to photograph it. Of course, there was no hole anymore, it had been repaired. So he photographed it, took the negatives back, and then simply added the hole in for himself. An early example of photoshopping, I guess. Having looked at it, the hole is simply far too big for the size of the meteorite, but never let the truth get in the way of a good story, is the old newspaper adage. Next slide, please. Just a few facts. As I say, December the 3rd, 1970, 4 fragments fell, weighing in total 13.4 kilograms. It's roughly 22 pounds in weight. The largest fragment was what we call the Easter Essendey, which is a farm in which it fell. Roughly 10.5 kilos, actually 10 there. And the other fragments were roughly 1 kilogram each, and they're called the Keithick, the Corston, and the Carsey, all local farm names where they fell. Next slide, please. Now, the interesting thing about this, and this is something that was noticed after the 4 were recovered, is that the 4 fall sites actually almost fall on a straight line running southeast to northwest between the towns. As you can see, there are Blairgowrie and Cooper Angus. They are almost also equally spaced apart, which is quite interesting as well. The Easter Essendey one is the largest one. It's in the most northwesterly one. You can probably just about make out there are rivers and 2 main rivers, 3 main rivers, and a loch just to the north. There are much smaller bodies of water in the area. So the thinking is that there are probably other fragments which fell into areas where they could not be recovered at the time. And given the weather that we have, they were probably eroded or weathered away anyway, so there's probably not much to collect these days. Next slide, please. Now, taking them individually, this is Easter Essendey, roughly 10.1 kilograms, 22 pounds. It fell into what's described as grass parkland, which was used for grazing sheep. The farm workers who were working in the field next door did hear something. They probably heard a dull thud, and they noticed that the sheep had scattered from the area where that. They went over to investigate later on and found the large fragment that it was. You can probably just about make out at the bottom of that image, there's a hole with some dirt thrown up, which is about as close as we can get to a crater in that. But as I said, the ground was extremely hard, and I don't think it would have, had it been wetter and damper, it probably would have sunk in a bit further. This was found on the day after the fall, which all of them were except for one. Next slide, please. And these are images of the actual one. The one on the left-hand side was taken by Henry Coates. Now, he's a figure which looms large in the story, and we'll come back to Henry later on. The one on the right is the actual specimen as it is today in our collection. You probably just about make out that there's a large piece taken off the end. This was done to make thin sections for examination and for the use of researchers in looking at the composition of the meteorite. Next slide, please. Next one is the Carsey. It fell close to a farmhouse in the farm called Carsey. It was actually observed to hit the ground. Now, this is an unusual occurrence indeed. Very few meteorites are actually seen to hit the ground by observers on the ground. They're often, like the Chelyabinsk one. There was, I think, one of the most famous meteorites of the last 10 years, where it fell in Siberia to almost amazing YouTube footage from dash cams, a well-publicized fall. But no one actually saw it fall and hit the ground. And it wasn't until much later, when they examined the area round about, that they found that frozen lake near the city had this huge hole in it. And they suspected, rightly enough, that it was caused by this very, very large meteorite. So the impact was seen by Mrs. Welsh, who lived in the farm, and actually saw the meteorite fell. Could we have the next slide, please? And this is a picture of Mrs. Welsh herself, and she's pointing with her walking stick to the hole in the ground where you can just about make out where the meteorite fell. There's a couple of other images in the archive at Perth Museum that show a policeman in the background, which I think was rather ominous. But yeah, she became famous for being one of the few people to actually see a meteorite hit the ground. And in the UK, I think there probably is very, very few others that have done so. Next, please. This is the one we've just talked about, the Keithic fragment, which went through the roof and featured in famous photograph. You can see this photograph is also attributed to Henry Coates. Henry Coates, well, I'll speak about him later, but he was the curator at Perth Museum and is largely responsible for gathering the information from people on the ground and people who had written in with their observations. Yes, I'm getting the red light now. If we can quickly go through a few other, if we could actually move forward maybe 2 or 3 slides. Yeah, this is the Corsten one, which is the last one. And again, please. Yeah, additionally, only 3 pieces recovered. A 4th was recovered after 4 days. Letters began appearing in the newspapers almost immediately with observations and comments. Professor Sampson at the Royal Observatory then asked people to send him eyewitness accounts, and these were then passed eventually to William Denning in Bristol, who was one of the most famous astronomers of the time. Next slide, please. And this is the actual letter from the Scotsman newspaper by R.A. Sampson. You can see that he details some of the story behind it. He also goes on to say, it's desirable from a scientific point of view to make the information as precise as possible. And with your permission, I would ask anyone who has definitely noted any feature or circumstance at first hand to be so good as to communicate it with me. And many people seem to have obliged. If we pass on to the next one, we can see another couple of letters that appeared. I chose these two. There's many, many of them, because these are the most northerly and most southerly observations of it. The places where they come from don't actually appear on the map, which I showed you earlier. They're so far north and south. But it just goes to show that the spread of people seeing it helped to, I think, work out the trajectory, the angle, and from many different points of view as well. So each adding to the story and to the final explanation. Interesting little bit at the bottom there. Australia, of course, was at the height of World War I, and we forget that many of the men and women were away at the front fighting and so on. Next slide, please. I'm trying to go through them as quickly as I can. But people did not just send in written, they sent in drawings, and this is a drawing sent in by a Mr. Duncan from Edinburgh of the meteorite, and you can see his very detailed, possibly slightly, with maybe a bit of artistic license in there, but it was a useful piece of work, and from his point of view, it would have been almost, not quite, but almost directly overhead as well, so that you're not giving any kind of clue to the angle of approach. Next one, please. Sorry. Now, from the results that were collected, Denning produced this chart showing directions from the observer seen by the numbers of people. There's 20 there plus several others, so it must have been probably about 30 or so actual observers on the ground who were members of the public who sent in information. Also, the last one heard by, so it was I think they were quite keen to know if a meteorite makes any sound when it enters. And there was an explosion, obviously, because when it entered the atmosphere at height of just a few kilometers, it broke up with a bang. And in fact, some people say there were 4 separate bangs, hence the 4 separate pieces. And these were all presented in Henry Coates' paper, which I'll briefly talk about. And next slide, please. And this is the drawing that Denning produced of the course of the meteorite from the observations sent in to him by Henry Coates and by members of the public to just track the course of the meteorite, how the angle that it approached, and as you can probably just about see, the 4 different fragments. Last slide, please. This very handsome, well-dressed chap, obviously curators in his day were better paid than the curators are these days, is Henry Coates. He was born in Philadelphia on Christmas Eve, 1859. He was part of the famous Coates family, who were thread manufacturers and weavers, and his father Andrew had come to the US to set up an American branch of the Coates business, which still exists today as Coates Group, but it was called J&P Coates. The interesting thing that I've yet to find out is why he had changed his surname from Coates, as in C-O-A-T-S, to Coates, C-O-A-T-E-S. We don't know. There's no explanation I can find other than Coates was a common name in Philadelphia at the time, a Quaker family, Coates, and there may well have been some connection there, but we don't know. And I think I'll just call it a day there and say thank you for listening, and I hope that you enjoyed the talk. And I'll gladly wait for any questions and answers later on. Thank you.
Great. Thanks, everybody. All those presentations were amazing. Fascinating stuff. I guess we'll get it started. We got some good questions that came in. This one's open to all presenters. So to what extent is the history of citizen science a history of inequality?
Which shall we? I mean,
Do you want to go?
Sure.
what order? Okay, yeah. I mean, I think, well, just from the material that I look at from the early modern period, it seems that the bar for citizenship is very high, even if it's not just a literal political meaning, but a kind of sense of membership. So there is that. But on the other hand, I mean, obviously there's a lot of fluid movement between different practitioners and those who are interested. So there isn't a single sort of standard as to why somebody is included as a professional. There's not like, you need to have a degree in so and so. I mean, examples like the one that I presented, Christoph Arnold. I mean, you have these sort of farmers. At the same time, though, there is sort of this like derogatory, sort of label attached to these people as sort of second rate. So there is that. I mean, I suppose there is a kind of shadow of elitism constantly. If you think about the medieval origins of Scientia, right, it just starts out as a university discipline. So it wasn't for everybody, but it expands over time.
Great.
Yeah,
Cristina?
I agree. Sorry. I think I agree in a sense that when you look back through history, even to the earliest recorded examples of particularly astronomy, which appear on cuneiform tablets from Sumeria, you have to kind of say, well, who actually recorded this information on these tablets? These were probably priests or people who were involved with that. So there is already a divide there between illiterate, if you want to call them that, people who may say something or they may speak about this, but it's actually the priests who interpret what's being seen. After all, in many ways, astronomy is possibly one of the easiest sciences to do, because all you need is good eyesight and a clear sky at night, and you can see many things. And indeed, until the invention of good, reliable telescopes, that's all astronomers had to go on, and a few instruments that were devised for that. So anyone could actually see. And particularly when you're thinking about meteorites, which are quite spectacular, if you like, phenomenon, and will cause people to, obviously question where they came from. Is it a good omen? Often associated with either good omen or bad omens. So it wasn't until I guess we start to see during the Enlightenment, the establishment of societies and academies, and the fact that these were taking away, if you like, be separate from the universities, who still, in some respects, were stuck in the medieval period when the churches controlled study. You had to be, after all, it was only recently that at Cambridge University, you had to be, anyone graduating had to be ordained into the Church of England. So, but the academies allowed interested amateurs, if you like, to come in with a certain degree of knowledge. After all, we talk about, one of the greatest amateurs of all time was Charles Darwin, who, in a sense, although he studied at Edinburgh and Cambridge, didn't graduate from any of these universities, and yet, his place in the pantheon is assured. But yeah, Alita, yeah. I think now we're moving in a much better direction. We can see that the public participation in these projects is quite widespread. And I think in my paper I talk about the BBC running a series called Stargazing, which invited members of the public to go out on a night when might be unusual for Scotland, a night without clouds and rain, and see the sky. And in fact, I think at least 3 exoplanets were discovered during the running of that series. So they have produced real science from members of the public, and I think that's to be applauded. It's going in the right direction, but maybe we're still tainted with that kind of elitism.
Yeah, just a very brief point on this. Yeah, I agree with what you have said. I actually also think that there is a lot of, we don't know a lot about the contributors, who were them. And because actually what I'm trying to do in my research work in Portugal is actually looking at the collectors. Who are them? Because the well-known people, we know who they are. They were mostly from aristocracy or people from religious people. But then there are the other names that are difficult and when we look at those files, we figure out that there are more participation than we thought at the beginning. So, of course, those that were producing science at the time, they could be more from an elite perspective way of seeing it. But then there are the others, and there were plenty of people contributing. As I mentioned, we have examples of fishermen contributing. So there were, but in the sense of contributing, not of doing actually science. They were willing to contribute with data. So I think there is an untold story, and of course we figure out some inequalities, but also because we don't know many of those people that were contributing to science and why they were doing that. And we should also look at that information and try to figure out actually who was that network of science producers.
Great, thanks. I'm going to move to another question that you just sparked there, and it comes from a comment you made in your presentation about how citizen science is done for the advancement of the country. So, to what extent is citizen science a nationalist endeavor? Cristina? You're muted, Cristina.
Sorry. Yeah, well, yes, I mentioned that, and actually it was because it was not in the sense of nationalism, but in that sense, not the bad thing. It's like Portugal was not very advanced in terms of science in comparison with other countries. And so that's why it's interesting to study the Portuguese case, because science and the director of the museum mentions that Portugal still needed to advance more in terms of scientific endeavor. And so it would be interesting to get more information to contribute to the advancement of the country. So because it was needed and because he was realizing that was important for the country. So that's the way it is seen, not as a nationalist thing, but as a way of contributing to the development of the country. That's the way it is. It is being mentioned, not like we want to be very proud. No, it's that we notice that science can improve the country, the quality of life, or whatever. So science is important for the development of any country, and we should work more on that. So we should all contribute for the advancement of science.
Great.
To add to this just very briefly, I'd say in the earlier periods, the more elite the Scientia was, actually the more cosmopolitan. So for instance, the Republic of Letters would be not tied to a national interest. But then in the Enlightenment, with these public royal academies, there are sort of national pushes towards, gathering information for the sake of that society. For instance, cameralism in parts of the Holy Roman Empire. So just adding that.
Thanks. I got one here from the audience. So considering the complications of the term citizen science, both in terms of citizenship and definitions of science, is there alternate language we could or should use to better describe the world of scientific inquiry before professionalization? Go ahead, Jin.
Okay, sorry, I feel like I'm hogging up there. Anyway, so yeah, I think sort of in my small field of sort of, pre-modern history of science, we tend to prefer the term history of knowledge or history of knowledge making, just to get away from the sort of post-19th century sense of science as just natural sciences. And I think if we sort of take this broad angle of history of knowledge making, we can look at various strata of where this knowledge-making process begins, goes, and then ultimately ends up, from, for instance, bookmaking and publishing all the way to collecting natural history, so on and so forth, as Christina's talk has touched upon. So yeah, I mean, I'm inclined a bit more towards history of knowledge making. So yeah, thanks.
Yes, I agree with you, Jin. Actually, that there is a lot of problems with the term citizen in citizen science, and also with the word science, as you were mentioning. So knowledge, many times, also when working in, as I mentioned, I work in science communication, and using the word science many times is a little bit creates some separation, and because science is always seen as something very hard, very difficult. It does not include all the fields. So many times we use the word knowledge instead of the word science to include also social sciences, the humanities, and use the word knowledge in this sense. Yeah, but actually, I like what you have mentioned, Jin.
Peter, do you have a comment on that, or shall we move on?
I don't really have much to say on that. I mean, I'm not heavily involved in any citizen science project, however you decide on it. I mean, I think I wanted to feature this story because, to me, there are some good examples within this very small, very limited story of members of the public observing a scientific phenomena and making a vital contribution to the end result, which is to calculate things regarding the weight, the initial speed, and so on. Yeah, I mean, the whole area is kind of can be a bit of a minefield. Terminology has always been a bit of a minefield in many of our branches of science. Citizen, there's a word that has more baggage than anything else in some respects. I don't have a problem with using the citizen science. I think in a way it's a very nice catch-all term for involving members of the public. You could say public science or public, public involvement in science. There's a whole other set of language you can use there, but citizen science is, I think it's a nice catch-all phrase that encompasses kind of what we want to do in citizen science. And until somebody comes up with a better phrase, I think I'll continue to use it.
Great.
Yeah, I just put very briefly. No, it's just that this term citizen science has been coming to discussion several times, and many people prefer to use also public participation in scientific research as a way. It's also very used many times. I prefer to use that one rather than citizen science because it can be more inclusive.
Great. I think we have time for one more. We've got a good one. Come from James Gibb at Smithsonian Environmental Research Center. We give folks the opportunity to take more central roles as the scientists rather than as technicians. They develop questions, methods, conduct analysis, and even present work at professional conferences. Are we a throwback to the 17th and 18th centuries? Jin-Woo?
Yes. Yes, I'm tempted to say yes, but unfortunately, I just feel like there's no going back. There's no going back to simpler times, easier times when you had this sort of fluid movement between the sciences. And in some ways, I feel like the so-called citizen participants of the 17th and 18th centuries were allowed to participate because they were technicians. For instance, watchmakers, calendar makers, artisans. There's a huge literature on that now, yes. So yes and no. I mean, I think there is a certain movement towards synthesizing, and I think that's really to be applauded. I don't really know going forward, but that is the sense I get. I feel like there are parallels and reverberations, but we can't quite go back to antediluvian times. So yes.
Yeah. Peter, what do you think about this?
Yeah, I agree. Absolutely, 100%. The period that we're talking about was a very almost unique period in history where we suddenly came from moving away from the scientific revolution of the post-Renaissance era into what has now become generally called the Enlightenment period. But this was also tied in with advances in education in many countries where members of the public were much more able to read and write than they were before. And therefore, those who were interested were able to possibly access journals like the Philosophical magazine from London and Edinburgh, where they could read about these great discoveries by people who were often not professional scientists. They were often just simply well-educated observers of life, of science, if you want to call it that. And they were then able to read about that and set up discussions in and around, particularly in Edinburgh, which was one of the centres of the Enlightenment in Scotland, and clubs were set up for discussions in that. Now, we don't know the details of these clubs, but we are assuming that very few of the ordinary members of the public would have gone along to that. But I'm certain one or two certainly did go into that. And in terms of writing papers, I've certainly been involved with papers that where the co-contributor was a member of the public and not a member of an institution or a museum of any kind. And their contribution was just as valuable and just as insightful as many others. And in fact, in terms of the museum, our problem is that with funding cuts, abounding in the museum world, it's often members of the public who can go into the field and collect specimens from locations all around Scotland and bring them to us, where we can then look at them. And if a paper does come out of it, then they will get full authorship when required. So, it's already happening, and I'm quite pleased to see that. Yeah, I agree with you. You can't really go back to those days. They were unique for that time, and we need to look to the future.
Great, Cristina, bring us home.
Fully agree with what was said. Nothing else to add.
Great.
Yeah.
Well, we have lots of great questions unanswered, but we'll have to look at them afterwards. I want to send a special thank you to all our presenters. This was a really fun panel, and to everybody who came out today. Please remember to join us at 3 p.m. for our next panel on transitions in citizen science with the GLOBE program during a global pandemic, shifting gears from data collection to data literacy. Again, thanks everybody again, and have a great afternoon.